All right, let's talk about one of the most powerful principles in all of C#, abstraction. We're going to break down how this one single idea can help you write code that's cleaner, way smarter, and so much easier to manage. You know the feeling, right? You're deep into a project and the code just starts to feel like a tangled mess. It's hard to read, a total pain to update, and honestly, it's just overwhelming. We've all been there. Well, guess what? There is a super elegant solution to that kind of complexity, and its name is abstraction. It's a core concept that really helps us manage all that chaos and build applications that are just better. So, what is abstraction really? Put simply, it's the art of hiding complexity. The best analogy is driving a car. You use a very simple interface, the steering wheel, the pedals, the gear shift. You don't need to know a single thing about internal combustion to get where you're going. Well, abstraction in programming does the exact same thing for us. It gives us a simple interface to control very complex operations. And this, right here, is the key takeaway for us as developers. We get to focus on what an object does, and we don't have to worry about how it does it. We want to work with a simple set of controls and just trust that all the complex machinery working behind the scenes is going to do its job. So why go through all the trouble? Oh, the benefits are huge. Abstraction just naturally leads to cleaner, more structured code. It separates different components from each other, which makes doing updates and maintenance way easier. And by only showing what's absolutely necessary, it can actually make your application more secure. It's a win all around. Okay, so how do we actually pull this off in C#? Well, the language gives us two main tools to work with. Let's start by looking at the first one, abstract classes. Think of an abstract class as a kind of partial blueprint. You can't build something directly from it, but it's an incredible starting point for other, more complete classes. It can set rules, saying, any class based on me must have this method, while also providing some default functionality that all of its child classes can share. Let's see that blueprint idea in some actual code. We've got an abstract vehicle class, and inside an abstract start method. Notice there's no code there, no curly braces with logic inside. It's just a rule. It doesn't say how a vehicle starts. It just says that any class that wants to be considered a vehicle must define a way to start. So then when the car class inherits from vehicle, it is forced to provide its own specific implementation, like starts with a key. Now onto our second tool, and this one takes abstraction a step further. If an abstract class is a blueprint, our next tool is more like a binding contract, and it's called an interface. Yup, if an abstract class is a blueprint, an interface is a super strict contract. It's just a list of rules. It only defines what methods a class has to have, with zero implementation details. Any class that uses an interface is basically signing on the dotted line, making a promise to fulfill every single part of that contract. So in this example, the iPayment interface is our contract. It demands one thing and one thing only, a process payment method. Any class that implements this, like our credit card payment class, is promising to have that method. And the real magic here is the flexibility. We could add a PayPal payment or crypto payment class tomorrow, and as long as they also honor that same iPayment contract, our system can handle them without any major rewrites. Okay, so we have two really powerful tools. And this leads us to that crucial question every developer has to ask: which one do I use and when? This table really helps clear things up. First, multiple inheritance. This one's a big deal. A class can only inherit from one abstract class, but it can implement multiple interfaces. That's a huge boost for flexibility. Next, method implementation. Abstract classes can provide some default code, while interfaces are pure contracts, no code allowed. And finally, access modifiers. You can have public, private, or protected members in an abstract class, whereas in an interface, they're all public by default. Your choice is going to depend entirely on the design you're aiming for. All right, let's take a moment and dig a little deeper. We're going to tackle a couple of the most common questions that pop up when talking about abstraction, just to make sure we've really got this locked in. This is a classic. And it's so easy to get them mixed up. They're both about hiding things, but, and this is the key, they hide things for totally different reasons. So here's the simplest way I've found to remember this. Abstraction is all about the design. It hides complexity to show you what something does. Encapsulation is all about data protection. It bundles data and methods together to protect how something does it. So abstraction simplifies the outside view, encapsulation protects the inside view. Another great question. Can we mix and match these tools? Can we combine their powers for something even better? And the answer is a huge yes. In fact, it's a really common and powerful pattern. Just picture a class that inherits its basic DNA from a single abstract character class, but then it also implements multiple ability interfaces, like say iFlyable or iStrong. It gets its core functionality from one place, and then it promises to have these extra capabilities from other places. You really do get the best of both worlds. Okay, let's bring this all home. We've gone through the theory, we've looked at the tools, but let's focus on the most important part, the why. Why does mastering abstraction actually matter for the projects you work on every day? This, right here, is the real payoff. Using abstraction correctly leads to a clean architecture and makes your code so much easier to test. It is the key to building systems that can grow and scale without breaking. In fact, it's a cornerstone of the solid principles, which are really the guidelines for writing modern, professional, and maintainable software. So, as we wrap things up, I'll leave you with this question to chew on. The next time you sit down to write some code, just think, where can I hide complexity? Where can I define a clear contract? How is abstraction going to make my next project better? Hey, if this explainer helped you get a better handle on abstraction, do us a favor and hit that like button. Share it with a friend, and make sure you're subscribed to Global Code Factory for more deep dives just like this one.
You can also follow us on all the social media platforms. Just search for Global Code Factory and check out our website at globalcodefactory.com. And just a quick reminder, all this content is for general educational purposes only. Thanks so much for watching.